No? Ready to go for the next? Okay, let's go for the next, right? So what does the next problem tell us? The next problem is about conservation of energy, right? Effects of thermodynamics. And it's asking us also to make an energy level diagram, right? Yes? Okay, let's do it. So what's the first step? What is the first step of this procedure that you're playing? Right? First step. First step is energy in the form of what? Heat, right? Correct? So that will be energy in the form of heat. That's why I will put Q. I will not put W, I will put Q. And that will be equal to, sign should be correct, sign, the symbol should be correct, the sign should be correct, plus or minus? Plus, how much? 2 joules. You have to understand from where the energy goes to where, right? What is your system? And it's going to be plus if the energy of the system goes up, right? How about the second step? Second step, what am I going to do, W or Q? W, right? You see, there's a lot of things involved. I see a little problem, but you should be careful here. So it's plus or minus? Plus. How much? 1 joule. And then third step is what? QW. Q. What's plus or minus? Minus, right? According to the problem, if you read it carefully, it's minus 3 joules. Okay. So now if you want to find the total change of internal energy, you will find just find to follow the delta U is equal to plus minus Q plus minus W. That's the weight in the reader. I like it this way. I think it's more clear. Right? And so now this is going to be equal to, you've got quite a few Q's here. It can be many, you see? It doesn't have to be only 2, it can be a lot. So it's going to be parenthesis. For the 2, right? It's going to be plus 2 joules minus 3 joules, because it's this one and that one, right? And then plus work. Only one kind, it's going to be plus 1 joule. If you do it this way, you will never make a mistake. Signs, parentheses, right? So that will give you what? 0 joules. What does that mean? It means that delta U is equal to 0, which means internal energy final is going to be equal to the initial. So whatever I did, I took in, took out, did kind of back and forth energy, but eventually really, when I started with, when I ended up, is the same internal energy, right? So now we're going to do the energy level diagram, yes? So what kind of energy we're talking about? Internal energy, right? So here is internal energy. Right? Here is internal energy. And we start with initial energy. Well, let's say this is our initial internal energy. Right there. And what do? I add 2 joules, so that will go up. And then I add 1 joule, half of it, so if this is, that's going to be half. This should be half and down. And it's addition, so that's why it goes up. It doesn't go down, and it's work. Plus 1 joules. And then what do? I take energy out in the form of heat, so it's going to go down. How much? 3. So this is 2 plus 1, 3, so it's going to go up in the same level. Because this is 2 and 1, 3, and it goes down 3, because it's minus in the form of heat, then we'll go to the same level, U final. Because we know U initial is equal to U final. You can see it. Pretty easy, right? So, energy level is not that hard, is it? No. Okay. Ready for the next problem? You want more or we should go home? More. I didn't know. So you mean that? So maybe I was wrong. You like a lot? You like chemistry a lot? They do? Really? How many people love chemistry? Let me see your hand. They just love chemistry. Let me see your hand. So why do you want more problems? If you don't love something, why do you want more of them? That doesn't make any sense, does it? Wait a minute, you guys, am I losing my mind or something? Am I losing my mind or something? You say, you don't say you love something, but you want more. So you mean you're doing some things that you really don't like? I don't know. You're relentless. Okay. Here's a similar problem I guess before.